Hello and welcome to the log solving day 2 video. In the last video we went over just a couple of rules. In this video we're going to go over the rest of them. So this is going to be a bit of a wild ride. Thank you for sticking with us. Let's get started. So this first one says calculate the following, and we have A, C, E, and G all looking fairly the same. Well, I take a look here. I need to find a way to cancel this out. And I remember in the last video I mentioned that anything can equal 1 if you have it to the power of 0. So we can rewrite this first one as log base 5 of 5 to the power of 0. And then I can cancel out my big bases and little bases, and I'm just going to be left with 0. I can do the same thing with C. So I can have log base 2 of 2 to the power of 0, because that's the same as 1, cancel out big base and little base, and be left with 0. You'll find you can do the same thing with E. You'll also find you can even do the same thing with G if you rewrite it with a base of E. So this goes into our first new rule, that log base something of 1, if you have 1 inside the argument, it's going to be 0. Done and done. Let's try B, D, F, and H. So if we take a look here, there we are. Just a reminder that anything without an exponent, we assume that exponent is 1. So in this case, when we cancel out our bases of 5, we're going to be left with our exponent of 1. If we do the same thing for part D, okay, we cancel out our big base and little base, we're left with the answer of 1. It's the same thing for problem F, same thing for problem H. So what we're saying is that if you have log base A of A, if you just have the exact same thing in your argument, no exponent, we're just going to assume that's 1. First two rules, done, easy. Let's try the next two. Oops. So we take a look at example 2. It says, we have said, that's the wrong thing. We have said that the function defined by g of x is equal to log base A of x and f of x is equal to a to the x are inverse functions. Oh, inverses. Remember when we did that? It wants us to evaluate f of g of x and g of f of x. So now we're showing that they are inverses. Well, let's try g of f of x first. So if we do g of f of x, we're going to get log base A of, instead of x, it'll be a to the power of x. And we know if big base and little base are the same. We cancel those out, getting x just like we're supposed to. We know these are inverses, so how do we solve these? Well, if we try f of g of x, we should also get x. So this is going to be a, and then instead of to the power of x, it'll be to the power of log base A of x. And we know we're supposed to get x. So again, we have big base and little base. If we cancel out big base and little base, we are going to get just our x. So since we're going through with inverses, let's write ourselves a sentence. Since f of g of x and g, of f of x both equal x, f of x and g of x are inverses of, each other. And what we've really done is we've really just shown two more rules. So that second one down here, this first one right here, we've practiced that one. We did that one a little bit in the last video. This one right here was the new one, saying, hey, even if you have a log in the exponent, as long as that little base is the same as the big base, you're still going to get x. So again, we just went through two more rules super fast. Let's keep on going. So we have 3 more rules on the next page that we are going to be discovering. So it wants us to compare the following expressions. So we have log base 2 of 32 versus log base 2 of 8 plus log base 2 of 4. So let's go through, solve how we can. Let's do the first one. So this first one here, I know I can rewrite 32 as 2 to the power of 5. So we log base 2 of 2 to the power of 5. I'll use the rule we were using on the previous page. Cancel out big base and little base, and I'm left with 5. Okay, cool. Well, let's see. If I take a look at log base 2 of 8, I know that's log base 2 of 2 to the power of 3 plus log base 2, and 4 can be written as 2 squared. If I cancel things out here, whoops, I am going to be left with 3 plus 2, or 5. Okay, so we do get the same answer. Now I have to think, how are these connected to each other? Well, if I take a look at 32 versus the 8 and the 4, this is really the same as log base 2 of 8 times 4. So what we're really saying here is if you have two logs of the same base being added together, you can multiply their insides. And if we scroll, you will see that's the first rule that we have right here. So two logs of the same base being added together, you can multiply your insides. It's kind of like the opposite of the product rule from our exponent rules. So let's try this again. So if we do example 4, log base 3 of 9, well that's log base 3 of 3 squared. Cancel out your big base and little base, and you get 2. Okay, so let's try this again with log base 3 of 27 minus log base 3 of 3. So log base 3 of 27, that's going to be log base 3 of 3 cubed minus log base 3, and this is just 3 to the power of 1. You can also know this is 1 by going back to our rules from the previous page. But once I cancel my big bases and little bases out here, I get 3 minus 1, or also 2. So when I look at the connection between these two examples, I see that, oh, well, what we really have is log base 3 of 27 over 3. So in this case, if you have two logs of the same base being subtracted from each other, you can divide their arguments or divide their insides. This is similar to the quotient rule for exponent rules, except opposite. Remember, logs and exponents are inverses of each other, so you're going to find a lot of the same things, but opposite. And again, you can see that rule down here at the bottom. You may be able to guess what our next rule is just by looking right here, but let's go through it anyway. So if I take a look at log of, that is 10,000, this can be written as log, remember this is base 10, to the power of 10 to the 4, so I cancel out big base and little base, so it'll just be 4. And if I try that over here, well, this is already a base of 10, and this exponent here is 1, so if I just cross out my 10s, I get 4 times 1, also known as 4. Now, the connection between these two is that we're going to get the same thing here if we just do log base 10, I guess you can say, of 10 to the power of 4. The only difference is that in this example over here on the right, the 4 is on the outside of the log. The example over here on the left, the 4 is an exponent on the inside. So we can take a little exponent here and bring it out to the front, or we can bring a coefficient out in the front and make it an exponent. So honestly, we've gone through almost all of our rules. There's only one rule left we have to go through, but we're going to go through that in a little bit. Let's take some time and just practice these. So if we take a look at the next page, we have 6 practice problems here. If we go through A, B, and C real fast, let's take a look. So let's see, A, B, and C. A, log base 4 of 4 to the negative 5. My bases cancel out. Just left with negative 5. Done. Let's see, problem B, e to the power of natural log of 2. Remember that that natural log has a base of e. So we can cancel that out and just be left with 2. For problem C, again, I can see this is 2 to the log base 2 of 11. Both those bases are the same. Cancel those out. I'm just left with 11. These are going really quick. Now, you'll notice that I did not use a calculator. So do not use a calculator for these. Sometimes I will have you use a calculator, but these are all just our log rules. So see what you can do. Let's take a look at problem D. We'll go through D, E, and F. So for problem D, I see that I have 2 logs of the same base, both of 8, being subtracted from each other. That means I'm going to divide their insides. So this is going to be log base 8 of 16 divided by 2. So the first number always goes on top. And this is log base 8 of 8, and that's going to be to the power of 1. So I look at this, oh, big base, little base are the same. Let's cancel those out, and I get my answer of 1. Not too bad. Let's try it again. So here I have 2 logs of the same base in example E, and they're being added together. So in this case, we're going to multiply our arguments or insides. So this will be log base 6, what's a 6, of 9 times 4, or log base 6 of 36. And we know that we can rewrite 36 as 6 to the power of 2. Once we can cancel out big base and little base, we end up with 2. Now let's try F, because F's just a little bit trickier. So for F, we have 5 to the power of all of this stuff inside here. Now that's a lot of stuff. Now what I'm going to do before I cancel things, I'm going to simplify this exponent as much as I possibly can. So this is going to be 5 to the power of log base 5 of 6 times 7. And the reason being is that I have 2 logs of the same base being added together. So I'm going to multiply their insides. And this is going to be 5 to the power of log base 5 of 42. And now I look and I go, okay, big base, little base are the same. We'll cancel those out. And we're just going to be left with 42. So again, I know I went through those kind of fast. Feel free to re-watch that last section, but just practice. Keep practice, keep practice. Let's go to something maybe a little bit more exciting. For the next few problems, we're going to expand our answers as much as possible. So we're not going to try to get like an x is equal to or anything. We're going to just expand as much as possible. The directions say write each expression as a sum and or difference of logarithms, so include that plus or minus, and then express powers as factors. So express powers as factors. So if there's something with like a square root or a cube root, make that an exponent, so don't leave it that way. So let's take a look at problem A. So we have log of 1 over x minus 3. Then we have the caveat here that x should be greater than 3. 1 because it can't be equal to 3, can't divide by 0. And then also you're not supposed to take the square root, or not square root, well yes, square root. But you're not supposed to take the log of a negative number. And we're going to talk about that a lot more in depth in the next video. But let's just take some time, expand this the best that we can. I see that I have 2 things here being divided by each other, and I know that our rule from the previous page, we did some division in part D, so now we're going backwards. We had 2 logs of the same base being subtracted from each other, so we divided their insides. Now we have 2 insides that are divided, so we're going to subtract those pieces from each other. So this is going to be log of 1, or your numerator, minus log of x minus 3. Okay, so let's see what we can do. We don't have any rules for when we're subtracting inside of a log, so we're going to leave that be. But log of 1, that's from our very first page. We know that log of 1, or anything inside there, is going to give us 0. So this is 0 minus log of x minus 3, or you can just write negative log of x minus 3. And we're just going to leave it there. We're not solving for x, so we don't need a solution set. This is as much as we could possibly expand. Let's try another one. So if we look at part D, part B, we're now dealing with a natural log. And I also see some multiplication inside here. So we have x times all of this stuff. And I know that when we were multiplying inside the argument, that came from adding 2 logs together, or natural logs. So the natural log of x plus the natural log of the square root of 1 plus x squared is what we have. However, remember, they asked us to write powers as factors, and that's also going to mean we're going to want them outside of the log, or natural log. So I'm going to rewrite the natural log of x plus natural log of double parenthesis 1 plus x squared to the power of 1/2, because square root is the same as to the power of 1/2. Now we're going to take this power of 1/2 and bring it out here so it becomes a factor. So if you have anything like that, take it out. We're not taking out the squared here because the squared only applies to the x and not to the 1, but we can take out the 1/2 because it applied to everything inside the argument. So the most expanded version of this is the natural log of x plus 1/2 times the natural log of 1 plus x squared. If it was possible to factor 1 plus x squared, I'd have you do that as well, but that would not work. So this is as far as we can go. So just you're using the rules the opposite way. So now you're expanding as far as you can go. I want you to keep on practicing. We're going to save C for the go formative. Yes, that one is particularly tricky looking. It can be done in just a few steps, I promise. So now that we've practiced expanding, let's try condensing. So if we go to the next few problems here, example 8, it says, write each expression as a single logarithm. So again, we're going to condense, make it as small as possible. So when I take a look at A, log base 2 of 1 over x plus log base 2 of 1 over x squared, I have two logs of the same base being added together. It means that I can multiply their insides. So this will be log base 2 of 1 over x times 1 over x squared. So I'm multiplying fractions. I'm just going to multiply straight across. This becomes log base 2 of 1 over, x cubed. And I'm fine if you leave it like this. You can change this into log base 2 of x to the power of negative 3 if you want, but this is condensed into a single logarithm, so I'm going to say that's good. Let's try it again. Part B is very, very similar. The only difference is that now we are subtracting the two logs instead of adding. So when we're adding, we multiplied inside the argument. Now we're going to be dividing inside the argument. So this will be log base 2 of 1 over x divided by 1 over x squared. So I am dividing their insides. And this double fraction, not a huge fan, so I'm going to write this the long ways instead. I'm also going to zoom in. So we'll have log base 2, 1 over x divided by 1 over x squared. And this will become log base 2 of 1 over x times x squared over 1. So if I multiply straight across, keep remembering to write your log base 2. So if I don't know what just happened. If I multiply, there we go, straight across in my argument, that's going to be, it's going to be x squared over x, and x squared divided by x will just leave me an x in the argument. So my final answer here is log base 2 of x. So keep in mind, this first step was the log rule. The rest of it was algebra. So again, if you're feeling shaky on your algebra, please keep practicing. Let's take a look at C, because C looks very interesting. So if we take a look at C, we have log of x squared plus 3x plus 2 minus 2 log of x plus 1. Oh boy. Okay, so first thing, I'm going to look in here. I'm going to factor this, because that's probably going to be a good idea. Something may cancel out later. So this will be log, let's see, I'm looking for two numbers that multiply to 2 and add to 3. So it's going to be x plus 2 and x plus 1. Notice I'm using that double parentheses there. And then for my next piece here, the reason I didn't divide the insides right away is because of this 2. I need to bring this 2 to be part of the log. So we're going to take the 2, bring it up here, and it's going to now become an exponent. Now, I want you to take a look at how I write this. Be minus log of parenthesis x plus 1 squared. So the 2 doesn't only go to the 1, it goes to the entire inside of the log or the argument. So be careful about that. But now we can divide our insides. So we now have two logs of the same base, in this case 10, being subtracted from each other. So let's divide their insides. It'll be log of x plus 2 over x plus 1 divided by x plus 1 squared. Well, if I kind of write this out the long way, it'll be log of x plus 2 times x plus 1 over x plus 1 times x plus 1, since that's what squared means. And I go, oh, you know what? Something does cancel out. Got that x plus 1 and that x plus 1, and we are left with log of x plus 2 over x plus 1. So it only took us a few steps, but we were able to simplify the whole thing into a single logarithm. Now, sometimes it takes more than 4 steps, such as problem D here. Problem D takes a little while depending on how many algebra steps you're showing. So of course, I'm going to leave this for you to try in the Go Formative. We will go over this together in class, but I do want you to try it on your own first. So that's all the practice we're doing with those rules. Like I said, there's one more rule we need to practice. This was also the only problem on this page. It's not going to take a whole page. That was just the one that was left. There's one more rule that we have to figure out, and that is our change in base formula. Now here's the thing about the change in base formula. Our calculators only know how to do base 10, so if we're dealing with a problem with like base 2 or base 5, how do we deal with that? Well, log base a of m is equal to log base m over log base a. And that's kind of it. So we'll take that, we'll plug that into a calculator. So use the change in base formula to write the following logarithmic expressions in terms of natural log or common log. Common log is just regular log. Then approximate each in your calculator. So we're going to round to the third decimal place here. I'm going to do 3 of these with you. I'll let you try the other on your own. So problem A, if I rewrite this, this is going to be log of 5, so my original argument, divided by log of 2 of my base. So this is my change in base formula. Notice it's not the arguments that are being divided, it's the whole log that's being divided. I take this, plug this into my calculator, I get 2.322. And that's the whole problem. So let's try it again. Problem B here would become log of 1/2 divided by log of 5, since that's what my base was. I plug this into my calculator, and I get negative 0.431. Let's do this once more. If I try this with problem C, I get log of 15 divided by log of 4. Now I can apply this, now I can put this into my calculator, and I get about 1.953. I'm going to leave problem D for you to do in the Go Formative. But this was actually the last of our practice. The last page in these notes is just all of our log rules kind of condensed into one place. There are a few I'm going to add on here. The first one being that we know what the base of a log should be. That's base 10, so don't forget that. We also know what the base of a natural log is going to be. It's going to be base E. And then in our last video, we also learned about kind of a rearrangement rule. So we had log with a base, an argument, and it was equal to something, so log bay. And you can rearrange that to be your base, your exponent, and that's going to be equal to your answer. So you can go back and forth and rearrange those. I've already taken a picture of this last page and put it on Go Formative on the Log Solving Day 2 page if you want to take a look at that and use that while you're practicing. So good luck, take some time to study these rules, and I will see you tomorrow.